We have Aarti here with us. She is a senior data scientist at Red Hat, and she'll be talking about LLMs and summarizations. But we are excited to have you here, so thank you so much for that. Let's get to it.
Thank you. Thank you everyone for joining here, and thank you PyData for giving me this opportunity. So I'm Aarti, and I work as a senior data scientist at Red Hat, and I worked on different AI or deep learning based applications like building the search engine, the recommendation system, chatbots, content generation, and also summarization. So like you can see from the title itself that I am going to be speaking about how you can build your own summarization using LLMs. So before I get started, let me quickly ask everyone here, have you ever faced a situation for your work or for your personal reasons to summarize anything? Yeah, I see a lot of hands up. So how many of you have actually tried summarizing using any LLM? It could be ChatGPT, Gemini. All right, that's a lot. Okay. What about using open source model? Has anyone actually used an open source model, deployed it, and run an end-to-end application? Okay, I see a lot of hands going down, very few of them. So that's what we're going to be covering today. So as you can see, we will start off with the introduction. I will be discussing what the problem statement was that we at Red Hat were facing. Then we'll move on to deciding which model should be used, which is the best for your use case. So we'll look into the commercial and the open source models. Post that, we will go ahead and learn something about document chunking. Why is it needed? When is it needed? And different ways one can do that. We will also discuss the different summarization techniques and based on your requirement, which one can you use? Finally, we'll learn some details about how to fine-tune your own model on your custom data set and evaluate them using certain metrics meant specially for summarization. And finally, we will touch upon the deployment part and we'll take any questions post that. Okay, so like I mentioned, I saw a lot of hands going up that summarization is really a very basic and an essential need these days. It could be for different reasons. I'm sure everyone sitting here has had their own reasons to summarize. You could have either needed it for books, for emails, creating MOMs for meetings, or research paper, news, and many other such use cases, right? And the entire reason why you're doing this is to extract or filter certain information out of this big document into a small, say a paragraph, which will give you every insight and detail. So let's say you're using it for a meeting. So what you would ideally want is that the entire 1 hour long meeting transcript should get converted into some actionable items, wherein you'll just have those details as to what are the next steps or what are the steps that are pending for future. Now, if I'm sure all of you have used Amazon, and it's a very good example wherein on the product page, you will see a summarization of the reviews. So now you don't have to go through all the reviews of every customer. Instead, you can just read that small summary and know whether the product is good or not and whether you should buy it or not. So that's about the introduction. Let's quickly jump to the problem statement that we had. So giving a brief about this, we at Red Hat have a lot of support engineers who work on support cases. What are those? These are the cases that a customer opens when they face any difficulty or issues with one of our products. And all of these cases are ranked based on the severity. So 4 out of 5 severity means that it has a very high business impact. So we follow something called as follow the sun, which basically means that a case is worked around 24/7. So once let's say I am an engineer and I get assigned a case, once I'm logging out at the end of the day, I have to make sure that I pass on this information to the next engineer who's sitting in a different geo. This is done so that it continues to be worked upon and we have an immediate resolution to it. So what does the engineer have to do? They have to manually write a handover note or a summary to ensure that the next engineer has all the important details and they don't have to go through the conversations or the comments that the previous engineer and the customer had exchanged. So in that case, as you can see, what were our pain points? It was a manual process, and the moment it's manual, we know that it's time consuming, and also there is some inconsistency because everyone has their own way of writing a summary. Also, the engineers spent a lot of time doing this rather than actually focusing on the work that they're supposed to be doing, that is resolving the issue. So that's when we came up with this idea, why not use LLMs for this? Why not bring in an AI solution and try generating summaries using an LLM? And of course, this is going to help us because it's going to reduce the time. It's going to be consistent because I can make sure that the output is in the format that I want. So once that was done, we knew what we want to do. The next question was, which model should I use? There are so many models available on Hugging Face or in the market right now. So which one is the best for you? Now, before you jump to that, you need to understand the two types of models that exist. One is the commercial model or commercial LLMs. So what are these? Everyone has used GPT or Gemini or Claude 3, all of these models that offer their APIs and you pay as you go. Basically, you pay for the tokens that you're using. These are the commercial models. You do not deploy them on your own system. This is already deployed. It's a pre-trained model. And these are really large parameter models. So in this case, what happens is these models are really good at their accuracy. The speed is good. You don't have to maintain anything. So is this the best model? Is this the model that I should go ahead with? Well, I don't think so. We also have a problem associated with it. And what's that? It's my data privacy issue. So as the company that I work in, we do have certain compliance issues, certain licenses that we are allowed to. And we're not allowed to send our customer sensitive information to any third party LLM. So that was a problem that we were facing with these commercial models. We then looked at the self-hosted models. What are these? These are the open source models that you can actually deploy on your own architecture. You can have your own companies or GPUs, and you can deploy it on that. And the best part is that your data remains private, there is no breach happening, and also you can fine-tune these models. But these models also come with certain disadvantage. What is that? You have to get your own GPU. There is a GPU cost associated with it, plus you have to maintain it. And also, since these models are not as large as compared to the previous ones, they have a limited context window. For anyone here who is not aware of what context windows are, they are nothing but the amount of information that the model can take in at a single go. So let's say if you're using a Mistral model, it only has Mistral's 7 billion model, it only has a 32K token size. So you cannot really stuff in your entire document at once. So that does have certain restrictions. But that will not affect the solution that we're building. How? We will go ahead with something called as document chunking. So now that we had finalized that we wanted to use a self-hosted model because of the privacy issues, the next step was to understand how to deal with the context window. And that's where document chunking came into picture. As the name suggests, you're just breaking down your entire document into small pieces. So to give you an example, we have a model here. Let's say it only has a 4K limit of context window, but my document is of 8K tokens. So the model will definitely throw an error if I just directly feed this document to my model. Instead, what I do is I break it down into multiple chunks. So you can see there are 4 chunks created here. And then finally this model, the context, your prompt and your output all together forms the context window, and this works with the model. There is no failure this time. Please note that you see all of the tokens to be 2K for each of the chunks, but that's not the case. It all depends on the type of chunking that you're using. So there are different strategies, as there is no one size fits all. So there's no one way to, I cannot say that, oh, fixed token is the best way one should go ahead with. That's not the case. It entirely depends on what kind of data are you dealing with, what is your data format. So like you can see here, there are 4 different types available. One is the fixed token, wherein you just mention, okay, I want it to be 200 tokens, and all of them will be 200 tokens, irrespective of the breaks. It could break the word in between as well, if the token size is reached. Recursive is something that is mostly, everyone who's starting off is recommended to use recursive because it uses line breaks. What that means is it will first break your entire document on line breaks, and then continue to join them until it's reached the context window. So in that sense, your sentences do not really get broken right in between, and they still have some semantic meaning to it. The semantic, as the name suggests, ensures that every sentence in your chunk is related to each other. They have enough similarity, and this helps in building any of your applications wherein you would need to use RAG, for example. And the last one is based on the kind of file format you're using. So we do have HTML, Markdown, or code, which already has inbuilt applications where you can split your files. So this is available in LangChain and Llama Index, so you don't really have to code it yourself, you can just use it directly. Now let's look at the summarization technique. So we know the model that we're using, we know that we are going to be chunking the document, but we also need to know which technique to use for summarization. So there are three options for you to go ahead with. The first one, you can see that that's the most basic one, right? If you do not need to do any chunking, let's say your token size is good enough for your model, there is no breaking required, you can just go ahead with the stuff method. As the name suggests, you just stuff it all in along with the prompt and feed it to the model, and you're going to get the results. But most of the cases, that's not what happens. The documents that you're using are definitely going to be bigger in size, let's say big PDFs or books. In that case, you have to go ahead with chunking. Now, you have two options when you're chunking. The first one is map reduce. What does map reduce do? So if you look closely, these three are the chunks that were created. I create a summary of each of these chunks. So 3 summaries for 3 chunks. That's the map part. You're mapping mapping 3 chunks to the 3 summaries. And then once the 3 summaries are created, the next step is to then use all of these 3 summaries to create a final one. That's where you're reducing them to a single summary. That's called the map reduce. Now, map reduce, as you can see from the diagram itself, is a parallel method. What it means is you do not need to individually treat each of these chunks. All chunks can be treated at once to generate the summary. So it's pretty fast. You can actually parallelize it. What happens with refine is that, again, there are 3 chunks being created, but the first chunk goes and the summary is outputted, and this summary is refined using the next chunk. So what that means, it's a step-by-step process wherein every previous summary is refined using the next chunk. So as you can see, it is a sequential step, and so it is going to be time consuming. Now, based on the type of summary that you want to build or the type of data that you're dealing with, you will have to take a call between these 2 methods, whether you are interested in the intermediate summaries. Like for our use case, we didn't really care if the intermediate summaries, they were not related to each other, they were independent. We just wanted to get a final one, and so we could just go ahead with the parallel flow. So we used map reduce and stuff. But if you think that for your use case you would need refine, then you can go ahead with it. Although, keep in mind, it will be time consuming. Alright, so that's about summarization techniques and how you can do it. But sometimes what happens is that, let's say, summarization is a process wherein you don't really need the information to be learned by the model, because that could keep on changing. Like in my case, I had support cases. Now, every support case differs from other support cases. So I'm not interested in telling the model how to learn those details of each support case. Instead, I wanted to learn that how can you have the correct format. So what that means is, let's say my summary, I wanted to generate certain fields, like these are the 4 fields. Every summary should have those 4 fields, all the points inside should be bulleted, and certain details that you would want your summary to have. So in that case, what comes handy is something called as InstructLab. So it's an open source AI community project. Anyone can contribute upstream. And what it does is that it enables fine-tuning of existing model, but it offers 2 different techniques. One is skills, and the other one is knowledge. So what does skills mean? Skills is basically when you're trying to teach the model to, let's say, write an email, or summarize this in a particular format, or write a knock-knock joke. That could be a skill. But what's knowledge? Knowledge is, let's say, I have certain Red Hat confidential data that I want to teach the model, so that next time when I ask a question about it, the model will be able to answer that. So that's where I would want to feed in a lot of my, let's say I have PDF documents that I would want the model to learn from. I'll just feed that in. So that's where knowledge comes into picture. Now, as you can see from my use case, I was more interested in the skills part, because I only wanted the model to learn how to output in the desired format that I was using. So another important benefit of using InstructLab is that it creates the data set for you. So training data is something that we've all struggled with. When you want to fine tune, now that we don't need any pre-training, we only fine tune models, but this fine tuning also requires few thousands of data set, and they have to be very clean and very precise to your own companies or your relevant data set. So how do you generate these data? Like, do you manually do it? Do you, even if you use certain feedbacks or certain existing available information, you have to make sure that it's correct in the right format. You'll have to do all of those testing and all of those data checks. So InstructLab does that for you. All you have to do is provide it with 5 or 6 examples, and it's going to create an entire data set depending on the number that you have provided. So let's say I want 1,000 of them. It will create 1,000 data sets for you based on the 5 examples that you've provided. And how does it do that? It has a teacher model and a student model. Student model is the one that you're trying to fine tune, and teacher is the one that's going to help create the data. Also, it's very affordable. You can actually run it on your local systems as well. You can fine tune these models in the quantized version on your system and do a quick POC before you actually go ahead and fine tune the final model. And yeah, there's just few commands, so even someone who's not a data scientist or does not know much about it can go ahead and do that. So that was about fine tuning. Now what comes after that? Fine, I have a model that's been fine tuned. I do need to compare my results. I do need to see that if my model is performing good enough or not. For that, we need evaluation. So evaluation, there are 3 different types of evaluation metrics that are available. So the first one is the overlap based. Now that's the most common metric that has been used for a very long time now. I'm sure everyone must have heard about Rouge or Blue scores. So these are basically precision or recall based n-gram metrics wherein you're trying to check the overlap of words. So for example, if I have an entire conversation, I'm trying to see if my summary contains those words that are present in the original text or not. Now, you can tell that this is not the most ideal way to evaluate your summaries, because every summary will have only a few wordings exactly similar to your original content, and sometimes you may end up penalizing a good summary because of this. The second one is the semantic based. As the name suggests, you're trying to see how similar your summary is to your existing, to maybe a ground truth summary or your original text. Now, in this case, again, you're basically relying on some embedding models, let's say BERT. So there's examples are BERT scorer. So what it does is it's using a BERT model and it's trying to generate embeddings for both your say original text or the ground truth summary and also the model generated summary, and then trying to see how relevant they are or how similar they are, and based on that it's trying to generate the final score. But again, it's not always reliable because similarity that we do know that there are certain terms that could be a part of my company or very related to my domain that the model may not be aware of, or there may be certain words the model may think are similar but may end up giving a good score. Like we have all heard of the bank example, the river bank and the bank that we have, the financial bank. So that's the semantic based method. Now we come to the LLM based method. Now this is really trending a lot these days. So how many of you have heard of using LLMs to evaluate LLMs? Okay, so that's something trending these days. The reason is because it's very difficult to manually evaluate your results. And it's not just for summarization, be it a chatbot, be it any other type of LLM generation or generative AI application that you're using. You still have to have a proper evaluation metric, and human evaluation is definitely not reliable. So that's where you use a different LLM, a bigger and a better LLM. So what I mean by that is, let's say I'm using Mistral 7B for my summarization task. I would prefer using a Mistral 13B or a Mixtral 8x7B, so a model that is proved to be better for evaluating it, right? So today we're going to be looking at 2 different ways that one can evaluate their summaries in the LLM based method. Alright, so the first one is called question answer generation, or CAGS. So it's a very simple metric. It basically consists of 2 scores. So what you do, you have a coverage score and you have an alignment score. The steps for both of them are very similar. The only way that they do it is different. So let's just go through it once. If you see, the coverage score is basically which uses the original context to generate certain questions. So the whole idea of CAGs is to generate certain questions and then answer them using another text. So generating the question using the original text and answering it using the summary. So what it does is it will generate questions using the original text, and these are close-ended questions. What that means is it will only be answered with a yes or a no. So once those questions are created, now it's totally up to you if you want 5 questions or 10 questions, how much you want to evaluate. And then those questions, along with the model-generated summary, is fed to the model again to answer them. So let's take an example that my original text contains something like PyData NYC 2024, whereas my summary for some reason had PyData 2023. Now in that case, if there's a question, is this talking about PyData NYC 2024, the summary is going to say a no, because the summary does not have it. Now you can see that means it's a contradiction. So it's basically telling you that this summary does not have the correct information, and it's going to be penalizing your summary for that. If it's correct, then you get a full score. That means it contains enough information from your original text in the summary. So that's the coverage score part. Similarly, you have something called as the alignment score. Alignment score, here you use the summary to create your questions. You're basically trying to check whether your summary or your model has hallucinated or not. So let's say sometimes we do see a lot of hallucination cases wherein the model tends to add some information that was not present in your original text at all. So in that case, once we have those questions being answered by the original text, we will know whether those questions were factually correct or whether they were hallucinating. So once we have both of these scores, we're going to combine them using mean or sum it up and then get a final score. So that is your final score for that particular summary. So you will know how good your summary is or how good your model is performing in terms of your results. One more thing to note is that this is a reference-free or a reference-less kind of a evaluation. You don't really need a ground truth for this. You can just use your original text that you had and the summary to evaluate it. But again, no one's stopping you from using it with the ground truth as well. Okay, so we come to the second method. Now this method is called geval. It is this clipping has been taken from the geval original paper. So please go ahead and read it if you want to. Now in this case, what happens is it's again a very simple method. You basically have in the prompt you're going to mention that what do you want to do. So I want to evaluate my summaries. And then I'm going to give it a criteria. Now what is a criteria? I could say that I want to check the coherence, the correctness, or the faithfulness of my summary. Now based on these two prompts, it's going to actually go ahead and create a chain of thought. Now what's a chain of thought? It's trying to tell itself, what am I supposed to do? A step-by-step process as to how should I proceed with this. So you can see that it's going to start off by first read the news article and then identify the key topics, then compare it, then score it. So that's like a chain of thought that it's created for itself. Now once that is done and once you have provided it with the input and original text and the summary, it's going to actually generate a score for you. Now you can see that it has a scale of 1 to 10. And then it also, it could be like a 1 to 5, whatever you would want to. And then final score is something that you can use similar to the one that we were talking in the previous method. Now this score will just tell you how good your your summary is. Another modification that you could do to this thing is you can remove this part of auto chain of thoughts. What that means is you can yourself provide what do you want. You can yourself tell the model that these are the steps that you need to follow and this is how you need to go ahead with, and directly proceed with the final results. So it's similar to the empty benchmark, if anyone's aware of it. It's a benchmark that's been used to evaluate models, especially for chatbot. So it uses a similar mechanism wherein it generates it using GPT and then finally compares the result and gives a score. So that was about the evaluation part. Now, once the evaluation is done, we would want to move ahead with the deployment part, like how do you deploy it. So we'll just look through quickly what are the technical stacks that we're using here. So for the model, we had Mistral and Granite, both of them are open source. For the framework, we were using LangChain. So for summarization and for chunking, both, you can go ahead with LangChain. For fine-tuning, we were using InstructLab. It's again an open source community project. For platform, we have the RHEL AI or the Red Hat Enterprise Linux AI, and the deployment is on the OpenShift AI. Alright, so this is the final LLM lifecycle, and this will basically cover the entire end-to-end flow as to how we are creating the summaries and how it's being displayed back to the user. So let me start with the user here. We have the user clicks on a button, say generate. They want to generate a summary. This thing is being supported by LangChain, so it goes ahead, it checks. So we have conversations between the engineer and the customer. So this conversation is basically in the form of comments, and we check the token size. If the token size is good enough, it fits the model, we go ahead with the stuff method that we discussed earlier. If not, we are basically going to chunk these documents into multiple chunks depending on our criteria, and then finally use the map reduce. So that's what you see here. This part, that is the existing summary, is something very specific to our use case, wherein we did have previous handover notes that we wanted to accommodate in the next summary. So once that is done, the next step is to do some pre-processing on your context, because we have a lot of logs, a lot of error logs, basically a lot of different commands. So we would want to make sure that everything is clean and any information is all perfect to go into the model. Once that is done, along with the prompt, we have the comments going in and also the initial summary, this existing summary if there was any. This goes to the model. My model could be anything. It could be a Mistral model out of the box, or it could be a Granite model that is fine-tuned. And then the last step here is to check for assertion. This is the assertions, which basically checks the output. So the idea here is to ensure that the final format is consistent. It has a consistent template that's being followed. So we just have certain assertions that we have built to ensure that. And then finally, if it's a success, it goes and is displayed to the user. Now this is one part of it if you're using the out-of-the-box model. What to do if you want to fine-tune? So when you're fine-tuning, again, you can just use InstructLab. You have the synthetic data generation in it, and the training data is something that it will create for you. You can go ahead and fine-tune your model with just few commands, and once that fine-tuning is finished, you need to evaluate your model based on the metrics that we just discussed, and then finally you can replace your original model with this fine-tuned model. So this entire thing is happening on OpenShift, and the fine-tuning is a part of the RHEL AI. Alright, so we're at the end of the discussion. Let me just quickly tell you what are the key takeaways here. So we started off by deciding which model is best for your use case. So whether it's a commercial one, whether it's a self-hosted model, it's all up to you to decide based on your company's compliance and the licensing. Then the second thing is to know how big is your document. Like, is it always going to be long enough? Is it just few paragraphs that can be dealt with without any kind of chunking? So that would be one important thing to keep in mind. Another thing would also be the type of structure or the format that you're dealing with. So like I mentioned, you have different ways of chunking for different file formats as well. You can go ahead and use that. The summarization technique is also dependent on the document chunking, so and how well are you, and what are the kind of summarization that you want to do. Whether you want to do map reduce or refine will be depending on your use case. And lastly, you would need to fine-tune your model if at all you feel that your current model is not adhering to the required template that you are doing with prompting as well. So you may need to change it and go, try fine-tuning with it. So these are the references. I'll be sharing the slides, and anyone who's interested in learning more about these different topics that I've covered can go ahead and look at it. And that's all. That's my LinkedIn profile. If anyone wants to add me, you can go ahead and do that, and I'm open to any questions.
I have a question on that diagram.
This one?
Yes. So isn't the map reduce happening after, so basically you chunk the documents in multiple places, then you give it to the model, each individual, and then you get the response aspect and the reducing happening, right? So that's what I want to confirm, because I see in the diagram the reduce is happening outside of the LLM.
No. So okay. So what I want to state here is that this goes for the map reduce. It's not happening in here. It will be happening inside it. It's just to show that if you're chunking, it will basically be taking the map reduce path. Otherwise, it will be taking the stuff.
Okay. Just and maybe I have one more question. The fine-tuning part happens how? Like, is it like the user saying, like through the prompt, or is it something that is happening programmatically?
Yeah, so you don't have to provide any prompt. Like I mentioned, it's just basic few command line, commands that you need to give. All you have to do is provide some examples of your data set. So it has a template that you need to follow. You have a YAML file that you need to put in, which will have certain question and answer or the way that you want your final output to look like. Based on those examples, just 5 or 6 of them, the model is going to create it on its own. So you do not have to do any prompting, or you don't have to do anything.
So what kind of input text you use, like works, research papers?
Sorry, can you repeat that?
I mean the input text, like
Okay,
books, research papers, or source code text.
Okay, so for our use case, is that?
Yeah, maybe it is.
Okay, so for our use case, we were using conversations, like I mentioned, the comments that was happening between the engineer and the customer. So they, whatever problems that the customer has, they put it on chat. So they're discussing that. They share their logs. They share their. So let's say the engineer asks for, why don't you run this command and send me the result that you get, and then probably I'll check. Then they'll send over those results. So those are the kind of comments and the conversation that's being fed to the model.
What model do you use to evaluate Mistral?
We use Mixtral 8x7B.
So how long is this assertion? Do you like a manual rules for those assertions?
Yeah, it's a very quick process. It's just basic, a function just, it's like a test, just checking that whether your final output is in the desired format or not.
Just for the format?
Just for the format, yes, that's true.
In one example, how long did it, maybe I missed it, how long did it took for the process to complete?
Like from the start?
Yeah, from the start.
Okay, so basically we started it, it took around 3 months for us to end it, because I'm also including the time when we were doing POCs, because we were also collecting feedbacks, how it's working. So that also ran for like 3 weeks so that we could collect enough. So we went live in 3 stages instead of just going directly live in production. So it took us 3 months. Okay.
Do you guys use historical data of the conversations to pre-train the context? Or is that, sorry, what I mean is that do you use your historical data to sort of pre-train the, to pre-process in the context?
So are you talking about the fine-tuning?
No, over there, pre-processing the context.
Okay, this one, right?
Yeah, that's right.
No, so this context here is basically these comments. So
Oh.
for every use case, let's say a new support case comes in for which I'm generating these summaries.
Okay.
That's my context, and that is what I'm pre-processing. So I'm just ensuring that everything is in place. If there are certain special characters that I would want to remove, because we would want to make sure that the token size stays as low as possible and remove any unnecessary character. So those are the basic pre-processing checks we do.
So you're not using RAG or something?
No, we don't need RAG in this.
What is the difference in the quags and rags, basically? Is that the same terminology, same concept?
CAGs and RAGs?
Yeah.
Okay, so CAGs is basically an evaluation metric. RAG is retrieval augmented generation, right? So where you are trying, you have multiple chunks, say stored in a vector database as embeddings. You're retrieving the most relevant to your question. So if I have a question, the RAG is going to go to the vector database, try to find the most similar chunk for that question, retrieve it, and then those, let's say I'm retrieving top 2. Those 2 contexts is going to go to the model using which it's going to answer. That's the RAG part. So that's a different flow. CAGs is only for evaluation. It's based on the question and answer method that I just So I was mentioning that we have a lot of data privacy issues. So the company has very strict compliance and licensing protocols that we need to follow, and we do not want to send any of our customer or internal or sensitive data outside to a third-party LLM.
Yeah, that makes sense. But I think he said that the Berkeley has the more flexible.
Yes, that's because, so if you look at the open source models, right, let's take a 7 million model. Now, these models have a smaller context window compared to GPT. Now, GPT has hundreds of millions of parameters, right? So it has a good token size. It will have around 100K plus token size. Gemini will have 1 million token size. But these are not the models that you can deploy on your own system. Like, these are really large models. So when you're dealing with open source, you have options like 7 billion, 13 billion, or 70 billion. So each size or each parameter size requires certain different GPU requirements. So the higher you go for the parameters, the more GPUs you require. So it's a trade-off between which model you want to use and the context.
Gotcha. Is that a commercial?
Yeah.
Sorry, I missed the first part. I worked with OpenShift, but as an OpenShift AI, like what's the benefit? I know the benefits of OpenShift itself.
Yeah.
With TechCon libraries and security with core OS. But what is it that your new offering is?
So here we have the option to, let's say, take an example of models, right? You're deploying it on GPU. So it will have your GPUs and you can scale it anytime you need. So let's say today I've deployed it on one GPU cluster, and tomorrow I see that my usage is increasing, my customer size is increasing. It will help you do that. You can upscale it anytime. You also have options where you can either manage it on your own, like you can either have someone manage it for you or have it self hosted on your system. So, and you can develop, deploy, try out. You have Jupyter notebooks as well. You have everything available in there. So you can try from the end-to-end flow there.
So depending on what I need to do, I can use a scale up, elastic way like
Yeah.
the GPUs. I also have a choice of, maybe I missed it, which LLM model to use and stuff like that.
Yes, you do. You can deploy any model that you want. So if depending on your resources, whichever model fits, you can
So
use.
I don't choose it from the OpenShift AI platform. I build it.
You can build it.
Any more questions? Well, I guess Aarti will be around.
Yeah.
So even after the presentation, you have some doubts or questions, you can always talk about. And thank you so much for joining us and for giving this presentation. We enjoyed it. And thank you all for coming.